So today we're going to be talking about electric fields and forces. This is chapter 16, and today we're going to discuss section 1 of this chapter, which is electric charges. So first you have to know the properties of electric charges. There are two types. There are two types of electric charges. Okay, there are protons, there are electrons. Okay, electrons are negative charges and protons are positive charges. And you have to also know that when a proton and an electron come in contact, there is attraction. But when a proton and a proton come in contact, there is repulsion, as well as when an electron and an electron come in contact, which means that basically, like charges repel, however, unlike charges, okay, attract. So here, in the first case, where you have a positive charge and a charge, you can see that they are repulsive from one another, as well as between negative and negative. However, between positive and negative, they are attractive to one another. So here there's an attraction. In these two cases, there is repulsion. So here, repulsion, and here, attraction. Okay? Now you also have to know an object is referred to as negatively charged if it has excess electrons. Okay, so let's say this is an object, okay, and there are a lot of negative charges. There's excess electrons, but there is a deficit in protons. Okay, that means that this is negatively charged. Okay, however, an object is referred to as positively charged if it has electron or an electron deficit. Okay, so for example, let's say we have an object, okay, and there are many protons, but a deficit in it has too little protons, which means it has too little electrons, which means it has an electron deficit. Okay, so here there are too many protons, so here it is positively charged. So you have to note that charge is neither created nor destroyed. Okay, so an object became negative or becomes negative or positive because of the transfer of electrons. And you should know that the amount of electrons lost by an object is equal to the amount of electrons gained by an object. So here, this is an example of what I meant in the amount of electrons lost is equal to the amount of electrons gained by an object. Here you have two objects. This is object number 1 and object number 2. They are both neutral, okay? They're both neutral. When these two come in contact, one of them will become one of them will lose the electrons, and the object that gained the electrons will become positively charged, negatively charged, right? And here you can see that 2 electrons were lost from object number 1, but also 2 electrons were gained by object number 2. So this proves that electric charge is always conserved, okay? Now, how do you calculate the charge of an object? We have this formula. Q is equal to positive or negative N times E. Now, what exactly is Q, what exactly is N, and what exactly is E? Okay, so E is basically the elementary, okay, charge, which is equal to 1.6 times 10 to the power of negative 19 coulombs. So the unit, remember the unit of charge is coulombs. And coulombs is written this way. Okay. Now, what exactly is N? What exactly is N? So N is basically the number of electrons gained or lost. And finally, Q is basically the charge of an object. So if a neutral object loses electrons, let's represent it that way, the formula would be Q is equal to positive N times E. However, if a neutral object gains electrons, then the formula would be Q equals negative N times E. Okay, so what if they give you an example that says when we rubbed a neutral balloon across our hair, it gained 10 to the power of 16 electrons. Calculate the charge of the balloon. Okay, so first we know that the formula is equal to negative N times E. Q equals negative N times E. Why is it negative N? Because the balloon gained electrons, okay? Because the balloon gained electrons, okay? So now we're going to just substitute the values. So Q is equal to negative 10 to the power of 16 times 1.6 times 10 to the power of negative 19, okay? Now, when you multiply these two numbers on your calculator, you will get negative 1.6 times 10 to the power of negative 3 coulombs. Okay, this is just a simple example in order for you to understand how to use this formula. Now, you should understand the difference between conductors and insulators. So, what exactly are conductors and what exactly are insulators? So, conductors and insulators. Now, what exactly are conductors and what are insulators? So conductors allow electrons to move freely throughout the solid. Okay? However, insulators, they limit the movement of the electrons. Okay? And here there are some examples of conductors and insulators. Here, silver is an example of conductors, as well as copper, which is one of the most known ones. Insulators are, for example, rubber, glass, oil, etc. Thank you for watching. Hope you understood something from what we covered in this video. If you have any questions, don't be afraid to leave them in the comment section down below or email me at educology.help@gmail.com. You can access notes for this lesson in the description box down below. Thank you for watching and hope you have a good day.